Hello everybody and welcome to the webinar. My name is Neil Cook and today's webinar is about machine design using modern design tools. Now I like to keep these webinars as interactive as possible, so if you've got some questions please ask them during the webinar and I'll answer them along the way or maybe at the end. If after the webinar you have some other questions, you can contact me via email, via Twitter, or also by the Onshape forums. I go on there every day. So if you've got a particularly technical question, please head over to the forums, ask them, and probably somebody will beat me to answering it because there's got some very knowledgeable experts on the forum. Okay, so I mentioned that we want to keep this interactive. So if you do have a question, you'll find on the GoToWebinar control panel, there's a little box there. You can type in the question and press send. That will list on my list here, and then I can answer them as they come in, or I will answer them at the end. I will hang around for 10 minutes or so at the end to answer any extra questions. Okay, let's dive straight in. So this webinar is based around an ebook that we published recently called Modern CAD for Machine Design. Now you can download this ebook from onshape.com. If you go to the Learn menu at the top and go down to ebooks and white papers, you can just enter a couple of details and download that PDF for free. The URL for the actual PDF is at the bottom there, but it's probably easier just to navigate via the website. Okay, before we kick in, let's in this ebook there is a number of case studies for customers. So I just wanted to start off with a quote from one of our customers called GKS Packaging, and Evo states that sometimes when he uses Onshape, he wonders why CAD systems didn't work like this before, and it's basically saying, that we simply did it that way because that's the way it was. And that's true. CAD has been around for a long, long time, and people just accept the status quo, accept the way things work, and just get on with it with all the things that go along with it. So when we talk about machine design, or in the ebook, it covers 6 particular areas, and these are challenges that machine designers face. So there's the speed and accuracy of the machine, so that's cycle times and accuracy of packaging and so on. The reliability of the machine, so how much downtime it might have. Flexibility in modular design, so talking about making things a little bit more easier to work, to swap out individual components or subassemblies, or generally just to make machine design more multi-product and multi-purpose, make it more usable for the end customer. Then, of course, we talk about communication. That's communicating with your customers, communicating with your suppliers and vendors, and also collaboration. This is then working with teams. And of course, teams can be in the same office or they could spread around the world. Now, these are typical design issues that are typical for machine designs, but really most of them can also be applied to any type of design. And what we're going to focus on today, because there isn't enough time to go through every aspect of this, we're going to focus on a mix of all these capabilities here. So I urge you to download the ebook to get more information on these topics. But what we'll take a look at is more of a general high-level overview of some of the unique selling points of Onshape that makes it or lends itself to complex machine design. And I'll also throw in there some live product demos as well, just to illustrate the point. And of course, that's not in the ebook, and this is why we do it in the webinar to show the product in action. Okay, so before we start, there really is one root to this entire problem. And, there are other things that we could talk about with machine design or any design in any industry, but 3D CAD has been around for 30 plus years. And back in the day, the only way you could store data that you generate from these CAD is in a file. And it's not just one file. It's essentially every part, assembly, and drawing has its own files. And these files really are the root of the problem. They make it difficult to communicate, difficult to collaborate, make it difficult to just share data. Files become corrupt, and there's lots of issues related just around this one topic, and I could talk about this all day, but obviously there is limited time. So I will refer to this in general, how Onshape eliminates the issues that are generated by the simple file. Okay, and if you look at this image, it's kind of, this is how we represent a team trying to work with old CAD systems and files everywhere. you get complete design gridlock. Now, if you imagine just real quickly, if you've got 4 designers and they each have their own CAD system, they must have the CAD system installed on their desktop or laptop machine, which needs to be highly spec'd. Software needs to be downloaded, installed, upgraded. You've got to deal with license codes. You have the issue with incompatible software versions if everybody doesn't upgrade at the same time. And generally, because you go through a third party, there's horror reports of mediocre customer support to help you out when things go wrong. Now, when each of these persons designs in CAD, they generate files, lots of files, and each person has their own files, and they're all generating hundreds and thousands of files. So when they try to start working together, this is when things start to go horribly wrong. Now, sharing files, there are many ways you could do it. You could do it FTP, you could do it by email, you could do it on a USB stick, but lots of issues there with file sharing and data security, especially with things like USB sticks and especially email as well, probably the most insecure way of sharing data. Then it's difficult to track who has the latest version, who's working on something. So if you're overwriting theirs or they're overwriting yours, if you're using PDM, you've got issues with checkout and locking files, and files are also very susceptible to crashes and data loss and corruption. Now, there are ways you can mitigate this by having a file server that's common that everybody can access. So it's a little bit easier to share those files. You can install a PDM system, which gives you more control. Okay, we'll come back to that in a little while. And you can even try and do like a PDM in the cloud or use a file sharing service like Dropbox. But the issue here is files. We've already mentioned that's the main problem, and there's just files everywhere. Once somebody shares files with somebody else, there's a copy of that file elsewhere in the ether, out there in the wild somewhere. Somebody else has got a copy of your data. Do they know if they've got the latest version or not? Perhaps they're machining to the wrong version. Who knows? There's complete chaos when it comes to sharing files. And if you're a user of 3D CAD or even Microsoft Word, you'll you'll recognize these issues. Once somebody emails you a Word document and they want you to make comments on it, you've got to email back a copy. And then who's got the latest copy? Who knows? Very difficult to manage. So let's take a look at some of the things that Onshape brings to the table. Now, one of the things that Onshape enables is being able to work on any type of hardware. And I'll talk about this in a little bit more detail why this is important. But you can have, to run something like SolidWorks or Inventor or CATIA, you need a powerful workstation with a good graphics card. Now, if you're working on large machine designs, I also recommend doing that for Onshape, because Onshape is very reliant on the local graphics card. Internet connection is not that important. It's the graphics card and possibly the CPU, which is important for large assemblies. I mean, something you can see on the screen there is tiny, so you don't need much in the way of computer horsepower. But if you're working on a large machine with tens of thousands of parts, invest in a good graphics card. It'd be worthwhile. Now, you can run on desktop machines, but you can also run on any hardware. So it could be a Windows laptop, it could be a MacBook, it could be a Chromebook, a Linux machine. Because Onshape runs in the cloud and it's browser-based, you can run on anything, even mobile devices as well. Now, the benefits of this is that you can start to use your data and work with your data with customers, with suppliers on site right there. So you can show people your models, you can edit the models. So if you're on a shop floor and you need to do a quick design change or do some quick measurements of your model, you can do that in real time with Onshape on a phone or a tablet. And people and customers are doing that on a daily basis. One such customer is Hyobotics. These guys make, well, as the name suggests, they make robots that they hire out. Okay, so one of the things that sold them Onshape was really the ability to run Onshape, not just as a viewer, but the entire CAD system on a phone or a tablet. So when they're out on the factory floor or they're with a customer, that being able to use Onshape is new and has really helped to leverage their time and make them faster. Okay, so again, this is another customer which is covered in detail within the ebook. Again, download it to read more. Next thing before I get into a live product demo is instant deployment. Now, Again, because CAD is installed on an individual device, something like SolidWorks, for example, you must download it, install it, license it, configure it. And if you've got more than one user, then of course you have to repeat that. Now, if you're doing it once, it's not so much a hassle really. But a typical CAD system has about 5 or 6 service packs a year. That requires a 40-minute download, and if you've got 5 users and a 22-minute install, and these are very conservative numbers, by the way, then you're talking 15 hours per year for a CAD administrator, or more likely your best engineer, upgrading everybody so they're on the same version. Okay, because of course you have to do it all in one block. You can't do it one individually, simply because you might get file incompatibilities. So typically people do this over the weekend, and it's a full weekend job doing all this time. If you do it during work hours, then you've also got to consider that your engineers are also going to be up to 15 hours per year down on time as well. So it soon mounts up just this method of installing and maintaining and keeping up to date your old CAD system. And there's also, an IT overhead associated with them. We've looked at expensive workstations, but really you need to implement PDM once you get these thousands of files. Managing them can be a nightmare. So PDM servers and clients. Then you got to manage things like your standard content and your drawing templates and custom properties. Do you put them on a shared network drive? Do you put them on VPN for people who are out of the office, which has its own complications added up? And then one thing that a lot of people don't consider upfront is just having robust backups. Now, Onshape gets around all this because all your data is stored on the cloud. So there is no backups required. We back up every 3 hours and integrity test that data, because a lot of the time when data is backed up on a local server, people don't really have a good recovery strategy. People don't test the backups to see if the integrity is good, simply because there's not enough time or resources to do that. So again, Onshape addresses that. And then the final thing I'll talk about briefly here is sharing CAD data. Now, if you think about a machine, then thousands and thousands of parts. It's not something that a single person can take on their own, unless they've got limitless time, which of course nobody does. So working together as a team is a mandate. There's no way getting around it. Now, in old CAD, if you have your CAD data, and again, you're generating all these files, managing data and sharing this data just using Windows Explorer, again, is virtually impossible. So you must invest in servers and PDM software and essentially become an IT guru overnight. Once those files are checked in, they're indexed by the database, and then anybody who wants to work on that data must then communicate with the database, and those files will be checked out again. Now, the issue here is that once the files are checked out, they are locked. So it means that nobody else can work on them. And this kind of flies in the face of kind of real-time collaboration. If somebody checks out a subassembly and you want to work on it, you can't until they've checked it back in again. So this creates a real serial workflow. Now, Onshape gets around this because, again, if there's a database in the cloud, you can have multiple people working on the same data at the same time. And also the other method that people share data, again, if you're using SolidWorks, not picking on those guys particularly, but anybody who uses file-based CAD must transmit it somehow. And the most common way to do that is via email. Sure, you can zip up all the parts and assemblies and drawings and send them in the email, but you have to consider things like email file size limitations. Is somebody using the latest version or not? There are lots of issues related to files being sent by email. It's very difficult to track where a file has gone and who's using it once it's left your desktop computer. Okay, and then we'll just talk about one other customer called Absolute Machinery, and typically they're talking about how they share and work on projects at the same time. So when old file-based CAD, it was difficult to see what people were doing, but with Onshape, they have immediate access to the CAD data on phones and tablets, And basically, if anybody wants a quote, they don't waste any time because Onshape helps them work together as a team at the same time and get the job done much faster. Okay, so we'll take a break there from the PowerPoint slides, and let's take a look at Onshape. All right, so when you first sign into Onshape, you're presented with essentially the documents or the projects that you're working on. So whereas PDM with traditional CAD is kind of like an add-on to manage files, Onshape is the other way around. It is a fully featured data management solution with CAD capabilities built in. So you start off with the PDM, or I shouldn't call it PDM. You start off with data management tools, and then you access your CAD data. And again, you can select whatever you want to work on, and then open that in a browser. Now, I'm running this on a MacBook, but I could be running it on a desktop machine. I could be running it on a on a Linux machine, on a phone or a tablet, and it's got a reasonable graphics card in here, so that so the rotation is quite smooth. It looks a little bit choppy on GoToMeeting. It's very smooth on my screen here. So, if you want to work with somebody else on a particular design, in the old CAD way, you would have to either email them the files, or you'd have to check the files into PDM, and there's no way you could actually work together at the same time. And that's completely gone in Onshape, and you can share data with somebody specifically by simply going to the share button in the top right corner. And you can see you can share with an individual, with a team, with the entire company. So if I was to share to, let me share to myself. Okay, so I share to myself, and then I can assign granular permissions. So if it was sharing with a supplier, then you might want to specify that they can view the document and they can add comments, but you don't want them to be able to export it in any kind of neutral format, for example. Again, this is a security feature, so it means that when we do this, very much like Google Docs, if you've ever used that when you add somebody's email in, we receive an email with a link, they can click it, it will open in the browser window, and they will see exactly what we can see without the capability to export or to edit the data. So very secure way of sharing data. Now, once that person has worked on a design or looked at it, made some comments, if it's a supplier, you may want to approve them as a supplier, and then change their editing permissions. So simply by specifying that they can export, for example, means that perhaps they're doing some CAM work on it. They've got to do some machining. So if they're using something like Mastercam, they'll want the file format in something like STEP or Parasolid. And when you share a document with a supplier, they get the option to export that in the format that they need. So you don't have to think about exporting step files and emailing them or anything like that. It's all taken care of at the other end. So again, it's just one more thing that you don't have to do or manage or take control of when working with third-party suppliers. If that person needs to edit it, so it could be a contractor, it could be somebody within your company, you can then give them edit permissions, and then they can edit it at the same time. Okay, so once that is done, like I say, that person will receive an email, and assuming I can get this to work, let's see. Okay, there we go. It does work. Okay, so this is my iPhone, and this is just to show what the experience looks like when you're working with a mobile device. So opening this assembly on the phone, again, I'm using Wi-Fi here. It works perfectly well on 4G. It's a little bit ropey on 3G. I wouldn't recommend it for large designs. For something smaller, it's fine. But 4G and Wi-Fi, it's absolutely fine. Now, what you'll see here is, so this is, the full machine here. But we're not looking at a viewer. This is actually the full CAD system. And at any time, you'll see that there is a queue here saying that somebody else is in this document. And if you double click that, I can then follow what the person on the phone is doing. So if I change the tab, to this screen. It will also change the tab on mine. So it's great for design reviews. You can see exactly what's going on. You can add comments. You can do multiple things with this in order to convey design intent or design changes that are required within an assembly. Now, what's really cool and unique to Onshape, because we're looking at the same data at the same time, is that you can edit it. So, for example, if I if I come in here and edit this sketch, okay, and let's look at the side. Now, what we'll see on the phone, if I expand that window, it's saying that here somebody's editing Skizze 3. This is in German. So somebody's editing that sketch. We can see that's at the same time. Okay, no problem. What am I going to do? Let's go in here and we'll add some fillets, and we'll add some fillets to this edge. And it's got some really unique selection capabilities as well. So, for example, if you wanted to zoom in, especially I'm using an iPhone 7 here, so it does have 3D touch. So if I press harder, it's going to zoom in and allows me to select that edge. So something simple like that. Again, from the website, I can see that this other person is creating a new feature. So bear in mind what we're doing here. We are editing the same part. Okay, and I'm going to say OK to that. So that fillet has been accepted there, but of course we can't see it because I'm editing this sketch, which is further up the tree. Let's just do something a little bit crazy, and let's go to sketch 3 here and edit it here. Now we're both editing the same sketch. So, if I go ahead and change this number, change that to 20, okay, you're going to see it change there. So this is completely unheard of in any kind of CAD system ever done before, being able to edit the same part, the same assembly, even the same sketch at the same time. So this is the definition of true collaboration. And just this feature alone can save hours of frustration and errors in complex machine designs. Now, what you'll see is then when I go ahead and press OK on that, of course, those fillets that I added on the mobile phone will appear on this feature here. And then we can go ahead and edit it or whatever we need to do. So there we have. So there's some editing one part, at the same time from two individual devices. So what I'll do here is I'll get rid of that, and what I'm going to do now is do the same sort of thing but with two windows, okay, because it's a little bit easier to do on the screen with two windows than using the phone. All right, so when we're working in the same document, and when we make changes, what you'll see is that there is no save button along here. Even if we look in here, there is no save button, because every time you do something in Onshape, it is recorded. So we'll see that we edited sketch 3, we inserted a feature, renamed a tab, and this essentially gives you unlimited undo redo. I can go backwards and forwards through this version history and see exactly how a design looked, weeks, months, years in the past. So there is no need to physically check files in order to record it. I don't need to worry about files on my desktop computer. I don't need to worry about things getting corrupt or lost. Everything that happens to this project will appear in this list here. And you can do comparisons, you can go backwards and forwards and so on. So for example, what I do here now is create a version. Now a version is simply a bookmark, if you like, because once you start getting a very large list of changes, you then it's basically essentially just a bookmark to be able to find your way around a particular design. Onshape Professional also does include release management capabilities that we could see here. I'm not going to go into that here, but you do have all these data management, complex data management capabilities built into Onshape without any extra software to be installed or administered. Okay, now what we'll do here is we'll take a look at some of the flexibility and modular design aspects of machine design. Now, it might be that you need to create multiple variations of a part. You might need to do multiple design iterations in order to make sure something is going to work as expected. So what somebody is able to do in a particular workspace, for example, is right click and create a branch. What this does, it essentially creates a sandbox environment, if you like, which enables somebody to make design changes without it affecting anybody else's work. So, for example, here now, as I start to come in here, and I'll let's edit those fillets there, and we'll make that say 2 millimeters, and let's make this thing a little bit. Let's make it a bit thinner. Yeah, something like that. I'm just making these design changes up as I go along. Perhaps add some chamfers on the edges. One there, for example. So nothing major, but they're just kind of design iterations, design changes. Now, what you'll notice here is that this hasn't changed. And again, because we're working in different workspaces, this enables multiple designers to do multiple design what-if studies, if you like, and then decide if those design changes are good. Once you decide those design changes are good, and you can do this by going, okay, well, let's do a comparison between that guy and that guy. You can then take a look at what changes have been done elsewhere and then decide if those changes should be included in your design or not. And I'm just going to stretch this screen over a little bit so you can see it a little bit better. And it tells us here that there's an extrude which is not the same, there's a fillet that's not the same, there's a chamfer that exists in one side but not the other. And this nice little slider gives you a visual representation of the differences between the two. So if you are quite happy with that, then then you can go back to your main design and then include those or merge those changes back to the main design. So this could be something which is essentially a version 1, which is in use by the customer. You want to include those changes. This is very easily done by merging that data into this current design. You'll see there within a couple of seconds there, you've now got the smaller fillets, the thinner beam, the chamfers added to the corners. So it's a nice, easy way to manage multiple design scenarios without having to do an entire save as copy, which you would have to do with old CAD using files, which gets very messy very quickly. Okay, let's jump over to some assembly related work. In fact, not that one. Let's use this sub-assembly here. Okay, now once we're working with assemblies, sub-assemblies, let me get rid of this window. I don't need this anymore. Then things like standard contents, things like nuts, bolts, screws, fasteners, that kind of thing. All this capability is built into Onshape. So again, you don't have to buy an extra toolbox. You don't have to administer it and put it on different on PDM servers or shared drives. Everything is built in. So for example, let me just zoom in a little bit closer here. So we're going to insert a new component and we'll look to standard content. And there is currently ANSI, DIN, and ISO. And then we can see here we'll include bolts and screws, hex head screws. You can size a screw by picking an edge, and that will then get you the correct one. So it's an M6, and then specify what that length should be. So let's go for a 35 thread length. Now, multiple ways you can insert this. I can pre-select this edge and select insert, and it's going to put it in there for me. You could select the face, and it'll fill all the holes in the face. But what's really cool about this is that these fasteners are intelligent in that if I now decide, well, actually I want to put a washer on this standard content, so I'm just going to go change. Let's go for washers, plain washers, and we know we need an M6. Now when I go to insert this, and I'll just drag it, and you'll see it's attached to my cursor. You can see there it is. But as we put it near the bolt head, you'll see the bolt head moves out of the way. Let me just zoom in there and do that again. The bolt head will move out of the way to enable the washer to position itself under the under the bolt. Likewise, you can do the same thing on the other side. Let's insert a washer here, and we'll place it there. Oh, actually, I should have put the nut in first just to demonstrate, but never mind. We're just putting the nut in there, and again, we'll insert that. And you can see you can put it under the washer if you want, or over the washer, which will give you the capability to do multiple stacks of washers and nuts and bolts, or whatever whatever you need to do in defining your design. And then once you've got bolts in, you can then there's multiple ways you can duplicate those. There's a very cool replicate command, which if you've used Onshape, you'll know. But what I'll do here is just change the pattern of these wheels, and we'll include those 4 items that we've added into that pattern. And there's our standard content. Okay, very easy to do. One of the things that makes machine design, there's a question there saying, can I make configurations in parts? Yes, you can. I'll come on to that shortly. One of the things which is very prevalent in machine design is standard parts, standard things like belts, chains, sprockets, gears. Again, all this stuff can be generated automatically, and we use this thing called feature script. Now, feature script is a built-in programming language, if you like, that people can build custom features. So you don't have to be able to program. You can actually just reuse somebody else's feature, and we'll see how this works. Now, it kind of a little bit like a macro, but it's more robust than that, and I'll show some examples. So, for example, here, this belt, let's get rid of that and create our own belt. Okay, so if we're going to create a belt in here, what we can do is use something called in-context editing, which is, if you're familiar with 3D CAD, it's basically a way to take references from other parts in an assembly. Onshape does it differently because, as you can see here, the assembly is ghosted out, but you can still make references to it. What's also unique about Onshape and in-context editing is that it cannot be broken. In other words, in old CAD, if a file is missing or it's corrupt or it's maybe read-only or something like that, a reference can easily be lost and your assembly falls over. Because Onshape is entirely database and timestamp driven, then this is the assembly as it appears at this point in time. And then if you need to make any changes, you can do that at a later date. Okay, so let's go ahead and make a belt. Now, this is using a custom feature. So we can see one up here. It's called belt. So this has been generated, actually, by one of my colleagues. But one of the unique things about these custom features is that they use the look and feel of a standard feature, and they behave like a standard feature. So let's go ahead and pick some faces. And as we do this, it's going to start generating a belt. And okay, and what we'll do is continue adding more faces. And what you'll see is that those are crossed over, and that's simply because it couldn't find a solution with those 4 belts. Now you can see it's starting to build the geometry that we need. Likewise, we can come over here, start adding these belts in, and it knows based on the order and how many belts there are that there's only really one solution to this problem. You can flip them over, but this is an example of a custom feature built within Onshape. So it's a 2.8 meter belt to go around all those pulleys in the design. And then once we're happy, we can just say insert that part, and that will then appear back in that excuse me, back in that subassembly. Okay, one other example I'd like to show is on a different document, and there's one here for creating or calculating conveyors. Now, if you've done anything with chain conveyors before, then you know how difficult it can be to calculate if you have a known length of conveyor that you need, is how many chain elements you want. Sorry. And a lot of it is trial and error. You might order more than you need, and then on the shop floor decide what sizes are. Of course, you need some kind of adjustable position as well. Now let's take a look at how we can do that in Onshape. So if we go for this particular feature called conveyor length, it's asking for a chain link. The connecting pins both sides, which is going to position it relative to itself. And from here, then it's then going to build my chain length for me. It's doing a few things. First of all, it's going to assemble all the parts together, but then it's also going to work out how many links it can get around the chain, and therefore what the length of the chain will be. Okay, so let's make that a bit bigger. And I know this thing needs to be 153.2 because that's the size of the sprocket that's going to go in there. And well, we'll leave it at 500, but that's going to then generate however many links it needs to actually fit around there. So working this out manually is a real pain because obviously the links don't follow an arc completely. So therefore, generating that, and let's just do one more change. Let's make that 700, make it a little bit bigger, and select OK on there. So when you actually come to create an assembly, you can see these things called make connectors, which allow me to position the sprockets. It just means that it's very easy to define something from the very beginning. And because these behave just like regular Onshape features, is that you can make a design change at any time. So if, for example, currently I've set this to 700 millimeters as the width of the length of the conveyor, if for some reason I need to make a design change, it is simply a feature in the list which I can go ahead and edit. Okay, now if I want to reuse that in an assembly, we can just insert that and reuse that as a design. So let's go ahead and insert that guy and fix it. And then when we go to insert some standard content, so this is the current document, but I can look for an existing document. So these could be organized by folders or by links, or anything that you want to specify with a particular design. I'm not going to be able to show that. So this is an example actually, and this is my own fault for not checking beforehand. But when I did the sharing capabilities before, there was an option there to disable people from using documents in other documents. So I'd need to go back and change that. I won't do that for now, but it's just an example there of the permissions capabilities within Onshape and how you can prevent people from using your work. Okay, the last thing I'd like to look at in Onshape, and just to answer Jay's question, is configurations. Now, the way we do configurations is entirely different to anything you may be used to in another CAD system. Now, you can drive it directly from a table, which is absolutely fine. So, for example, I might want to create a configuration. Let's and we'll call them so small, medium, and large. And then the thing I'm going to configure is perhaps the bore diameter. Okay, so this is what you may be used to in a traditional old CAD system, where you got this thing, make it 5, 7, 9, and then you can then change the configuration, and it's going to rebuild the model or the little subassembly there based on these new dimensions. Now, what makes Onshape different is that you can drive multiple variables in multiple different tables. So if this particular cylinder had so someone's asking, does Onshape use design tables? This is exactly what we're looking at here. So you can use design tables like here. We're showing a design table, so you can actually see that data in a tabular format to drive your design. However, in an example like this with a cylinder, where it might have a fixed bore, but it has a variable length, and it might have multiple different port locations, if you were to do every permutation for those options in a table, you would end up with a table with hundreds, if not thousands, of rows. And in fact, when you configure a cylinder, it might say between 100 and 2 meters is your stroke, and everyone is built to order. So how do we do this in Onshape? Well, we can keep this here, or we can change it to a variable. We can add another table. So rather than just have one table drive the design, we'll do it as two tables. In fact, let's do a different type of table. And this time we'll do a variable as a table. So what I'm interested in here is the stroke. And this is going to be, I can't remember what the numbers are now. So you might go default 8, minimum 6, maximum 30 inches or something like that. So this defines the stroke. Now, because it's not table driven, what we need to do then is go to the stroke and specify that to set to stroke. So now what you'll find is that the length of the cylinder, and therefore the stroke, is defined by a variable. So we can go ahead in here and type in any value, 12.5 for example, and it's going to rebuild the part for that. So with just 3 table entries and 1 variable, we've essentially already got infinite numbers of variations. Now when you start to consider things like port locations front and back, I'll just do 1 rather than 2, just for brevity. But we might to go top, left, or right are the options, for example. And here then we're going to configure the feature, and it's going to be one of these, and we're going to configure this angle. So this is basically going to move which ports, I can't remember which one it is, and it's going to be 0, 90, or 180. I might even have the values wrong, it doesn't matter. But it means that now I can got an extra input, so I can define it. I want to be a medium at 20 inch, and I want the one of the ports, it's the front port. There you go, so it appears over here. So you can, so it could be left, it could be right. Actually, it's bottom, doesn't matter. In fact, let me change it now just to make sure it is right. Make that 270. So that appears on the right hand side. So it enables you to build these configurations. A very powerful way of building many different types into 1 or 2 or 3 very simple tables. And again, just to do something like that would be 30 plus rows or something in a regular design table. And again, you can suppress or unsuppress features, as Jay is asking there. So again, you can just take anything here and you say configure suppression, and you can add the suppression to any of the tables that we've already created here. So that could be a part of it. So for example, so let's suppress that as list input 1, and it's then going to be a checkbox. So if we suppress that, it's basically suppress the cutout, which was this feature here. So again, so you got full control over feature size and feature suppression. And again, for machine design, of course, it's very important because you have all these different ways of making a design modular to for different packaging capabilities or anything else that machine might do. Okay, so let's just head back to a couple of slides. One of the things I mentioned about, again, the dreaded file is that they can become, they can become corrupt from files crashing. Now, from the application crashing. So it could be like, SolidWorks or any kind of 3D CAD does crash a lot, and it's not necessarily their fault. It's the very nature of the beast. It's very complex software, and they're very reliant on the underpinning technologies like Parasolid Kernel and D-Cubed Sketcher and the OpenGL graphics libraries. If one of those things goes wrong, then SolidWorks has no option but to crash. There's a very bold statement there. It says Onshape never crashes. These are quotes from our customers. Of course, Onshape crashes, but the way the architecture of how it works is that because it's all online through a web browser, is that if a low-level component like a parasol kernel does crash, there's another instance of that component waiting to take over, and within a couple of milliseconds, that's taken over. So from a user standpoint, you will never even notice that anything has happened. Likewise, from just crashes and lost data from that standpoint, it's estimated that 30% of files, CAD files, over their lifetime will become missing or corrupt. Missing in that you've emailed it to someone or put it on a USB stick, you don't know where it is. Corrupt in that something's happened to it, it's got a virus or whatever. And this can be broken down into things like hardware failures, human error, you've deleted something by accident, you dropped the laptop and broken it, file corruption, hard drives crash, applications crash while saving data, hardware theft, computer viruses, hardware destruction, flood lightning, that kind of thing. None of these things relate to Onshape at all, primarily because there are no files, but because all your data is stored in a secure cloud workspace, there is nothing local to your machine. So it doesn't matter if you dropped the machine, there was a fire in the office, the things got stolen, your data would always be safe. And it also means that because that data is in one location, is that you don't have to be attached to one single machine. You saw a moment ago as I have the web app and the mobile app working side by side. I can be in the office working on a desktop machine, working on a large complex assembly. Next minute, I could be on the train going to a customer's premises on the phone making more changes. So you just literally carry on where you left off or work simultaneously at the same time. So Voxel Innovations are very used to this thing, and basically saying that when they're using file-based CAD, I believe it was SolidWorks, but I might be wrong, is that it always crashed a lot. So when they have working on very complex things and designs and concepts that they didn't have or they didn't want to save because they were in the progress of making changes. If you keep saving and then decide later, actually, I prefer the previous version, then you kind of saved over your best work. Of course, that doesn't apply in Onshape because you can use the version history graph and go backwards and forwards at any point in time. But if there's a crash, in old CAD, you have to start over. Anything you've done since your last save is gone forever. But Onshape, everything is saved, and people do struggle. And in fact, what a lot of people say is that now they try to use something like, Microsoft Word, and they forget to press the save button and close it, and then lose all the work, even without it crashing. So something you get used to. It's a little bit unnerving at first when you say, where's the save button? Everything you do is saved and recorded for the lifetime of that document. One last thing I want to mention about Onshape as a company rather than a product is the resources that we provide free of charge to our users. First of all, there is online self-paced training videos. If you go to learn.onshape.com, you can do these training videos yourself. These include bite-sized snippets of 2 or 3 minute long videos with exercises allowing you to go along with the designs and be able to work and see what you've learned as you go on. Also, from a support standpoint, it's software, so there's always going to be bugs of some description somewhere. If you do come across an issue, and it could be a bug in the software, it could be a how-to question, I don't know how to do something. I prefer actually if people go to the forum to ask the how-to questions because there's so many people active on there to go and answer those questions. However, you can use our support mechanism to ask a how-to question, and it's all done directly from within the product. So there is no, because it's runs in a browser, you don't have to collect what kind of machine you're working on or what kind of setup you have and what graphics card you're using, that kind of thing. You don't need to do that. Literally just draw on the screen, explain the problem, share the document with Onshape Support if you wish a quicker response, and we'll get back to you extremely quickly, mostly within a few hours. What's also unique to Onshape is that there are regular updates. So we do a release every 3 weeks, and that release has a dozen or so new features. These are all improvements which have been requested by customers. And again, if you go to the forums, you can request your own improvements, and enough people vote, it'll get prioritized and pushed to the top of the list, and more likely to get implemented sooner. Okay, got a question here saying, can I save my models in multiple versions of SolidWorks depending on my customer preferences? So you can save data in SolidWorks format, but it's in something like SolidWorks 2004 format, I believe. So it means that it's openable by any SolidWorks application, which is at least less than 12 years old. Of course, when you transfer data from one format to another, you're going to lose any of your feature data, or your design intent and your design history is going to be stripped out because it's only going to transfer a solid body. And that's typical between any CAD system, but it is possible. And it is possible to read a CATIA file and save it as a SolidWorks file, so you can use it as a translation tool as well. All right, so regardless of the machine design ebook, which again I urge you to download and take a read of, we've looked at 6 generic reasons why you should consider switching to Onshape, and those are the minimal hardware requirements. You can run it on any machine, on a laptop, on a phone. Instant deployment, all you need is somebody's email address to get them up and running quickly, so there's no downloads, installs. There's zero IT overhead because you don't have to install expensive servers or have these expensive hardware set up, shared drives, manage a PDM system, that kind of thing. It's real-time collaboration, as we've seen, have multiple people working on the same document. Data is always safe, it's never lost or corrupt, and you can go back at any point, any time. And the training and support, if you go to a software comparison website like G2 Crowd or Capterra and take a look at some of the reviews that come from our customers, one of the things mentioned most is support. So, they give us a 5-star rating for support, which is kind of unheard of in the CAD industry because that's notoriously bad. But we kind of shine in that area. So people get up and running faster with Onshape from a standpoint of installing and working with it. They get up faster because there's the free training, so you don't have to go off-site somewhere and pay through the nose for some classroom training. We do, by the way, offer online classroom training, which works out something like 8 hours a week in 2-hour sessions. So that capability is there if you need it, but most people just go for the self-paced video training. And that finally, the last thing I then just mention again is, again, just to plug the ebook. You can get this data again from the Onshape website, and you'll also see there's other interesting ebooks on there. For example, there's an ebook on data security. There's an ebook on minimum hardware requirements. There's a ton of different ebooks on there that you might find interesting. So take a poke around and see if there's anything there that you like, and go ahead and download those for free. Okay, question here. What is the minimum internet speed required latency in megabits per second? Now, what is the most important thing for Onshape is latency. So we'll see here as when we first open a document, let's just go ahead and open this document again. So this here now is using your bandwidth because it's first of all got to load the graphic data and the feature data. So that point really is the only time that you're using bandwidth. Obviously, if you're opening a larger assembly, it's going to take a little bit more time. But all it's doing here is streaming graphic data local to the browser and streaming the feature data to here. So this is now, as I'm rotating this is running solely in the browser. So there's no connection whatsoever to the servers. Okay, it's when you make a design change. So if I change this thing to right and you see the spinner come up at the bottom here, that is then communicating with the servers, and it is just sending small packets of data backwards and forwards. So it's not having to update the model and send the whole thing down again. It's just small packets of data. So the important thing for a good experience is latency. I can't put a figure on it, to be honest, but anything less than 100 milliseconds latency is absolutely fine. I think I've got if you press Control D on your inside the Onshape browser, you can see exactly what you've got here. So I'm running at a ping time of 39 milliseconds, and I'm getting a frame rate of 20 30 plus frames per second in here. And that's probably slowed down because I'm running GoToWebinar at the same time. So normally I'd have a lower ping time than that. But that gives you an idea of the kind of performance that you can expect from a connection. Like I mentioned previously, from a mobile standpoint, it will run on 3G for smaller parts and assemblies. 4G, it runs absolutely fine, and obviously Wi-Fi is the better option to take if you're working with documents on your phone. But it does mean that as long as you've got at least a 3G connection, then you can pull up assemblies and parts on your phone and work with them without any problem. Okay, so that's all I wanted to talk about today. Please, if you've got any more questions, please type them in. And like I say, I will hang around for 10 minutes or so to see if there's any more questions pop up. But with that, I'd like to thank you for your time and have a nice day.